Welcome to Brain Vision.
In this problem, we're asked to determine the tension in 3 wires that are used to support a 44 kilogram chandelier. To begin, we have to understand that Newton's second law is going to be the relationship that we use in order to determine the tension. Newton's second law states that the sum of all forces acting on the chandelier equal m times a. To determine the sum of the forces, it's best to start by drawing a visual representation of those forces. That's called a free body diagram. So to do that, I'll draw the 4 forces acting on the chandelier, starting with its weight. The weight of the chandelier acts downward towards the surface of Earth, and it has a strength of m times g. And if you plug in that the mass is 44 kilograms, you'll find that the weight of this chandelier is 431.2 newtons. Don't forget that on Earth, the acceleration due to gravity is 9.8 meters per square second. The other forces that you need to include in your free body diagram are the 3 forces due to tension, each acting along one of the wires. Now, because all 3 wires are identical, they provide the same amount of tension. So your arrows should act along the wires, but all be approximately the same length in your diagram. And you should label them all with the same letter, and I'll use capital T. Now notice that each wire acts in a different direction and at an angle with respect to the vertical. This means that each tension is going to have 2 components, a horizontal and a vertical component. Now I'm going to look at the vertical components because I know that this chandelier is in equilibrium, meaning its acceleration is no longer changing and it's 0. That will allow me to relate the vertical components of the tension force to the object's weight. So, returning to Newton's second law, I can express that the sum of the forces acting on the chandelier is equal to 3 vertical components of tension. So I'll write it as 3 times Ty. That's 1 vertical component of tension for each wire, minus, because it's acting in the opposite direction, the weight of the chandelier. And that equals the mass of the chandelier multiplied by the acceleration. A couple of simplifications that we can make right away are on the right-hand side of the equation. We know the mass of the chandelier is 44, and we can also identify, though not explicitly stated, that the chandelier's acceleration is 0. It's at rest and remaining at rest. So the entire right-hand side of this equation turns into 0. This allows us to relate the tension in the wire to the weight of the chandelier. Our equation becomes 3 times Ty minus the weight of the chandelier, which I'll express as W, equals 0. So we turn our attention now to determining this term, tension in the vertical direction of any one of the wires. On this page, I've provided a diagram of any one of the wires, doesn't matter which one. It shows that the wire is supporting the chandelier at a height of 1.5 meters below the ceiling, and that the length of the chandelier's wire is 2 meters. This will set an angle between the wire, which provides the tension force, and the vertical direction. Now, the reason that I'm drawing this diagram is to highlight the relationship between the wire's tension and the vertical component of that tension, which I'm representing in green. A vertical arrow represents Ty, and this blue arrow along the hypotenuse represents the total tension in the wire. The angle between the blue arrow and the green arrow is the same as the angle between the wire and the vertical component. If we set up a trigonometric relationship between the hypotenuse and the vertical side of that triangle that I've drawn, we'll use the cosine function, where cosine of the angle theta is equal to the adjacent side, 1.5, divided by the length of the hypotenuse, which is 2.0. But we could express this equivalently in terms of the tension forces. So let me say that this equals the adjacent tension, which is Ty, divided by the tension that acts along the hypotenuse, or just capital T. So now we have a relationship between Ty and the total tension, which looks like this. The total tension, I'm sorry, let me back up, use a different color. The tension in the vertical direction, Ty, is equal to 1.5 divided by 2 multiplied by the total tension in the wire. This is an important relationship for us to use in order to solve the equation that we arrived at on the first page. So we'll do our problem solving on the final page. I'll rewrite the equation from page 1. 3 times the vertical component of the tension equals the weight of the object. And instead of writing Ty, I'll express it in the same way. I'll make a substitution. I'll express it in the same way that I've written here. So 3 times Ty, or 1.5, divided by 2, times the total tension, equals the weight of the chandelier. And from the first page, we know that the weight of the chandelier is 431.2 newtons, and that equals, I'll do a little bit of multiplication, 4.5 divided by 2 times the total tension in the wire. And now it's just a matter of multiplying both sides of this equation by 2 and dividing by 4.5, and you can determine that the total tension in the wire is 192 newtons.